All right, so we are on learning objective 6. This is still in chapter 17, and we are going to calculate the initial, final, or final mass, half-life, time passed, number of half-lives passed of a radioisotope. So this is all using the half-life equation. Learning objectives 3, 4, and 5. Yes, 3, 4, and 5 were done in class. So if you do not have those notes, you may want to see Mrs. Cole. I want to get some, help with it, because I'm not doing a video on it. So, half-life. Is the time it takes for a radioisotope to decay by a half or 50%. It is abbreviated as T 1/2. And the unit is some sort of unit of time. It can be minutes, seconds, hours, days, years, millions of years, billions of years, thousands of years. So it can be any of those things, right? In one half-life, half of the isotope, of the parent isotope, this is unstable, decays into a daughter isotope, which is more stable. Again, this is to a degree, okay? And it is a completely different atom. So this is a completely different atom. I no longer have the parent isotope. It's completely gone, okay? Half of it is, anyway. Half of it still remains. So the formulas for this are mass final is equal to mass initial times 0.5 raised to the n. Okay. So the things for this, the m sub f is mass final, m sub I is mass initial, n is the number of half-lives that have passed. Now, we have to calculate the number of half-lives that have passed, and the way we do that is by taking n is equal to the time passed, so this is abbreviated as T, over the half-life, which is T 1/2. Okay. Now, there is an equation that you might have to use depending on if you don't have a perfect half-life, that type of thing. So another equation that can be used. So if I'm using this equation to solve for n, the way I do that is I take the log of the mass final divided by the mass initial. And that's equal to n, which is what I'm going to be looking for, times the log of 0.5. Okay. Doing that calculation and solving for n, that will give me the number of half-lives that have passed if I'm not given anything but the mass final and the mass initial. Okay. All right. So you may actually have to be required to convert time units into one another. So knowing so in order to do this, you may need to know some numbers, some things right? So you should know that there's 60 seconds in 1 minute, and that there's 60 minutes in an hour, and that there's 24 hours in a day, and that there's 365 days in a year. I mean, you also have 7 days in a week. These are the things that you would need to know for that. So, for an example, cesium-137 has a half-life of a really large number in minutes. If 56.7 years have passed, how many half-lives have cesium gone through? So, if I have 15,000 or 15,804,800 minutes, I need to convert that into years. So I need to get from minutes into years, right? So then I know that there's 60 minutes in an hour. So 60 minutes, 1 hour. And then I know that there are 24 hours in a day. And that there's about 365 days in 1 year. And that's going to get me out of minutes and into days. So then I can go to my calculator, right, and type all this in. Remember, anything that's on the bottom, it's the same thing for like any type of stoic, any type of dimensional analysis. Anything that's on the bottom, you're going to hit divide by. Anything that's on the top, it's multiplied by. So 15,804,800 divided by 60 divided by 24 divided by 365. That gives me 30.07 years. So 30.07 years is the half-life. So this is T1 half. Okay. So if I have 56.7 years, this is the time, right? Time passed. And I'm going to divide that by the 30.07 years. And that's going to give me my N, which is my number of half-lives. So then I can go back to my calculator, 56.7. If I've got one of these nice calculators, then I can just go and click second answer. And that's going to give me that number that's there equals 1.89 half-lives have passed. And there's no unit for the half-life because if I'm in years and years, my years and years cancel. So there's no half-life. It's just a number. Okay. So the next one. If I start with 517 grams of cesium, so this would be my initial mass. So this is mass initial. How much is left after 150 years? So the 150 years is my time passed. So this is just T. So time passed. So, and I have the half-life over here, right? So my T1 half is right here. So this is my half-life, right? So I need to first, and most likely this is what you're always going to do, right, is I'm going to find the number of half-lives. So N is equal to the time over the half-life. So that's equal to 150 divided by 30.07. And that's going to give me, that gives me 4.99. So almost 5. Now, because this is really close to 5, I can say it's about 5. And there's two ways that I can solve this problem because it's given me a pretty good whole number here. So the first way, and this is the way that I would prefer, but again, if it helps you to do it the other way, you can do it the other way, is just plugging it into the equation. So my mass final is equal to my mass initial times 0.5 raised to the n. So this is equal to the 517 times 0.5 raised to the 4.99. So then I go back to my calculator and I can plug all that stuff in. 517 times 0.5 raised to the 4.99. If you wanted to be really, really precise on this, you could just put answer, right, to second answer. And then that gives me 16.287. So it gives me this really long number. I'm going to go with my sig figs right here with what I was given in my initial mass. So 16.2, 16.3. This is grams of CS 137. Now, the second way that I could do this, and again, I haven't gone through a whole 5 half-lives, but I'm close enough to be able to do this. So the second way that I could do it, I could take my 517, right, and divide it by 2. And that's going to give me a number, right? Give me an answer. And then I could divide it by 2 again. So that's 1 half-life, right? And then I could divide that answer by 2. And then divide that answer by 2. And that's 2. This is 3. And then 4. And then this would be 5. Okay. So doing it this way, I'm going to take the 517 divided by 2. Well, the first number it gives me is 258.5. And then I can take that number and divide it by 2. That gives me 129.25. And then I can take that answer and divide it by 2 again, and that gives me 64.625. And then I can take that answer divided by 2 again, and that's going to give me 32.3125. And then I could divide it by 2 for the 5th time, and it's going to give me 16.156, which is close enough to my answer. It gives me 16.2 grams, which is very similar to one another. So they're pretty close. So that is how you can do. So like this is way 1, which again is kind of the preferred way. And then you have way 2, like you can do it again another way, a different way. So whichever one makes sense to you is whatever you want to do. If you're doing it as way 2, you have to show your work for everything, for every step that you do, showing that I'm going through 5 different half-lives. And then that's how you go about doing that. With way 1, all you're doing is plugging it into the formula but you are showing work for all of this. Either one you do, you have to do this calculation, this first calculation for the number of half-lives that have passed. So that is learning objective 6, which is actually the end of nuclear chemistry. But that is your learning objective 6. Calculate the initial mass, final mass, half-life, time passed, or number of half-lives of a radioisotope.